Mechanical project using metric units. Today we're going to take a look at creating this bearing here using metric units in solid modeling techniques. Since it's a metric drawing, we're going to want to use a metric title block, and so I've placed those title blocks here in D2L. Students can download the metric title block and open it. And the metric, everything is scaled 25.4 times bigger. So as you start to work with conversion of imperial units or inches in metric units, the magic numbers are 25.4 and 0.0394 as we go through and we work with these different conversions. And so here we have the metric title block. If we look at it in paper space, I did put a point at the 0 position, and I just like to do that so that I can tie machine 0 and part 0 together if I'm producing prototypes. And we're going to take a look at the exercise now. And so if we go to module 2, here's our drawing exercise right here. I'm just going to work it right off of the D2L. And so the way the shape is set up here, what we're going to do is we're going to start at the center here of this view, and we'll create a 24 millimeter diameter circle, and then we'll create another circle which is going to be 60 millimeters. And what we'll do is we'll create this basic shape of the bottom, and then we'll extrude that, and we'll do the same thing here. I usually don't make these as primitives and cylinders, but we can certainly do that. Different methods for different ways of creating the same thing. It's just personal preference with AutoCAD. And so we'll work off of this shape two-dimensionally, and then we'll turn that into 3D. So let's get started. So again, here's my metric title block. If I go to paper space or model space, here I am in model space. If I want to go and check, I can show the menu bar, and I like to start these off in a workspace for drafting and annotation, since we do the 2D or the sketches first. And so that's where we're at. I'm on the object layer, and I'm going to start off by drawing a 24 millimeter circle, center diameter, at my 0 position. I'm going to use node, and I'm going to say 24. Do you have to put it at machine 0? No, or part 0. But it's not a bad way to go if you start tying these things to CAD/CAM machines. We'll make another, wake that point up, and this one's going to be 60. Switch over to a center line layer. We'll draw some construction lines. I'm not sure if my snap is on, so if I come back here, there it is. So that it hits on my 0 point. There we go. And that's more than enough. You want that to track out. Like with polar tracking, you can actually see that. You don't necessarily need the grid on, but when you create a line, you see how that green line tracks at 90 degrees. That's what you want. And then we'll offset that line. This one right here, to locate this circle right here. Sorry about that. For this circle right here. And so that's located, if we take 64, or that's 84 rather, 84 divided by 2, that'll be 42. So we'll offset 42. Try that again. create the geometry. And then we'll create a line tangent between these two. Actually, before we do that, we need an 18 radius. And then we can create a line. And with the O snaps, you can go into the object snap settings, make sure that tangent is enabled. But a lot of times what happens is it doesn't grab the tangent O snap. And so what I'll do is I'll shift right mouse click and select tangent. It's just faster, and it brings that object snap to the top of the list. Shift right mouse click, and then I'll do that again. So that's the technique I prefer to use. And then rather than mirror it, I just do it again at the bottom. If there is an error, I don't want to compound it, but you could theoretically mirror that. And then we'll clean this up, and then we'll mirror it to the other side using the trim command. You want closed boundary shapes, meaning endpoint to endpoint, and you want to avoid anything that would be like this. You want nice, clean, smooth transitions for your boundaries. We're going to mirror that shape. About this axis, and then we'll trim this. Alrighty, so that's what our base is going to look like, and it has a thickness of 12 millimeters. And so we're going to extrude that 12 millimeters. And there's two ways to do that. We can either press pull it, or we can use the extrude command. Now, press pull is a more advanced command, because press pull actually will create a macro that creates a boundary shape, a closed polyline shape, and then applies an extrusion so that you get a solid rather than a surface. And I'll show you what I mean. So if we do a quick save in case we make any errors. What we want to do is either turn off the center line layer or delete the center lines. I really don't need these, so I just delete them, because I'm going to probably put them back in when I do the 2D detailing. And when we work with AutoCAD and doing the 3D modeling, you'll keep your sketches separate from your models, at least at this point in the course. And so what we'll do here is we will grab an isometric view, orientate that onto the screen, and I'm just going to make a copy of it so that when I do create the dimensions and everything in the 2D, I'll have a separate sketch for that. And so I'm going to say take this and just move a copy of it off to left field here. All right. Now I can get rid of the center lines as we're modeling. Those will get in the way. What'll happen is it will divide. So if I try to press pull it, and we'll go to a workspace, I'll demonstrate that. So we'll put those back, and then we'll toggle over to a 3D workspace. I like to go right into the modeling rather than to some light modeling aspect of it, but you're welcome to use either one. And then if we were to press pull, like I was saying, it's a stronger command, but as you can see, if I have the center lines there, it divides it up into pieces. And yes, you can union them together and put it together, but we're not going to do that. So I'm going to delete this out, as well as this. I'll do my detailing and annotation at a different point. This is just a point. I like to leave it there. It's not going to make any difference. And then press pull is a more efficient command. So if I press pull it and then I bring that up 12, we're good to go. We're pretty well set. I'm going to undo that. And then I'm going to do that again. I'm also going to create a layer. I'm just going to type in the word layer. Actually, I'm going to, here is layer. And I like to create my 3D geometry on the 3D layer. And so I'm just going to say 3D. And I'll make that a shade of blue that's just slightly different. Set that current. And now when I model it, those objects will be on that layer. So as I go through, if I were to extrude this, what happens is I get something like this. And these are valid shapes for solid surfaces. And surface modeling isn't going to allow us to do 3D printing. It's good for CAD CAM, but we want to use solids. And so that's the difference between the press pull command and just the straight up extrude command. If you use the straight up extrude command, you have to have a closed polygon or boundary shape. So if I were to extrude the circle, since that's a closed shape, this would be a solid. And that's 3D printable, and we can do things like Boolean operations like subtract on it. But if you just straight up extrude it, you'll get a surface. And so if you are going to use the extrude command, and sometimes we have to, what you want to do is in the draw command, you want to make a region out of the shape. So it's a little bit more work, like I said, and then you can extrude it to that height, and you have to extrude the circles and subtract them. So it's a lot more work to use the extrude command over the press pull, but sometimes you have to. So I'm just going to go, and that was the explanation. I'm going to press pull it, and we're going to get this done. And so we're going to make that 12 millimeters. And then what we're going to do is we're going to work on the top edge of here, and we're going to create a cylinder that's going to be 60 millimeters in diameter and 34 millimeters in height. And so we'll go and we'll get cylinder. I'll hover and acquire the 3D snap at the top. And then I'll bring that out. And it's really the same spot as right here. So I'll just let the O-snap do the work and grab it. It's actually coming up a little short. It says 29.76. And so it depends on how you track that out. I guess if we want it to be perfect, we want it to track just like that at 90 degrees, and we'll type in 30. And then we'll bring that up to a height of 34. And I believe that's not the compounded height. It could be 12 too high. Sometimes the blueprints are difficult to read since it says 34 here, but I don't know if this is the termination or if this is the termination. So we'll determine that as we take a look at the model. These are typical of what happens with these author things. All right. So then we're going to put another cylinder 35 36 by 7. Again, I'm going to track this out. It doesn't matter on this one. And so this one is going to be a radius of half of 36, which would be 15 plus 3, 18, and a height of 7. And we're going to push it and type 7. And if you want, go to wireframe to see that, subtract it, and you will toggle back and forth. I mean, you can use X-ray and things like that, but the graphic cards and things like that, depending on your computer, wireframe works better. You just start to get used to being able to work with wireframe because it's a stronger way to get things done. And we'll go to subtract. We'll select this piece right here. We'll hit enter. This piece here and hit enter. Verify it. Looks great. Now I didn't union the bottom on it yet. I will get to that. But there's only one more feature that we need, and that's this hole that comes in at 14 millimeters off and to the side. And those can be a little bit tricky to put in because we're looking at a different orientation. And it kind of depends. This is a good reason for us to have that point because we have a point at the 0 position or at the center of it. And if we drew a line up in the Z height, we could calculate that out. And so if we go in and we calculate that, what we could do is we could take the total height, 34, 44, 45, 46, minus 14. So that would be 32 to here. And so let's give that a try. So we're going to go back to our wireframe and see here's my point. And then just to be good at demonstrating this, I'm going to use the center line layer. You don't have to. And I'll draw a line. And we're going to see if we can get that to acquire it to the node. And then as I bring that up, see, I don't want a 45. I want that to be in the Z height. And so I'm not getting that filter. And so I'm going to say shift at 0, 0, 32. And then I'm going to hit escape. And I'm going to see that that's in the right orientation, which it is. And then I'm going to draw a circle at that point, but it's going to need to be at a different UCS orientation. So as we work with the UCS, let's talk a little bit about how we would manipulate the XY axis. And so what I'll typically do is I'll just put the origin at that point. And so I'll just say, I'll go to my UCS command, which is in this group right here, and I'll just say UCS origin. And again, they don't always show the commands I want, so I'm just going to type it in, UCS, and then I'm going to type O for origin, and I'm going to put it right on the endpoint of that line. And so now my XY axis is right there. And then if I wanted to, I can go and create the orientation of that cylinder, but I have to change the XY axis of rotation because you always draw in the XY axis, meaning this will draw a circle right here. But if I want that circle to be at a different angle, what I do is I can say UCS, and then I can rotate it. And so I can rotate it, and I just do it by eye. I'll say rotate it about the x-axis and we'll say 90 degrees and see if that's the one I want. And it's almost the one I want. It's going the other way. Okay, and so now if I draw a circle, it's the orientation coming out to the front of the bearing, not to the side of it. So I just do it again, but I'll do a UCS about the 90 on the y-axis. And so you just say UCS, and then you just choose a different axis. You say Y, and you say 90. Now it's in the right direction. If I were to create a cylinder or a circle, if I can grab it. And so it is fighting with me, to kind of get that. I'm going to turn off my snap with F.